Welcome to Business Industrial Network Training. This module covers Protective Relay Essentials. It is designed to provide product knowledge for all levels from beginner to expert. At the conclusion of this module, you can register to receive your certificate of completion. Be sure to take advantage of obtaining this documentation. It will serve as proof that you completed the course. Now let's get started. Here's the outline of what this module will cover. We'll go over some basics of protective relaying. Protective relay components will be illustrated. We will explain protective zones. Relay types as well as the different types of construction will be handled. How relays are applied will be mentioned. The characteristics and why you use relays for different types of protection will be analyzed. ANSI uses a numbering system for different types of protection, and these will be handled. Throughout the module, we'll be comparing induction disk relays with solid-state and microprocessor relays. We will also include how microprocessor-based relays can combine protective features and include metering. Finally, we will go over the selection factors for protective relays, followed by a summary of the lesson. For all of the quiz questions, click on your answer, then click on Submit to continue, and then follow the on-screen instructions. Relays can be used to monitor a variety of parameters such as under and over voltage. As an example, overvoltage conditions can be monitored with an IEEE device number 59, similar to this photo. Current is probably one of the most applied relays. The most common is a 5051 device, instantaneous overcurrent relay. Protective relays also monitor power to ensure it is flowing in the proper direction. An example would be a reverse power relay, device number 32R. Other power applications are to monitor power levels, either low or high, and could include a device number 46 for phase balance and directional power 32P. Controlling frequency is a major concern for systems. Costly damage to equipment can result from an over or under frequency condition. Device number 81O for over and 81U for under are the proper selection as seen here. The Basler BE1-11T relay helps. Here's a closer look at the indicating contact switch. The ICS unit is commonly used to provide a seal-in around the main protective relay contacts. It consists of the magnetic frame, the coil, residual pin, moving contact, armature, core, mainsprings, and target indicator. The IIT unit seen here operates as an instantaneous overcurrent or as an instantaneous trip unit. Its adjustable core provides pickup adjustment over a nominal 4-to-1 range. It consists of an adjustable core as mentioned, coil, core, lag loop, armature, moving contact, and target indicator. Induction relays are available as a standalone instantaneous overcurrent protective device known as a device 50. A combination time overcurrent and instantaneous relay is also available, and it's labeled the device 50/51. A standalone time. Solid-state relays mimic the performance of induction disk relays. In this diagram, we modified the relay section to help demonstrate how this works. Inputs to the relays are provided by the PTs and CTs. Settings are made to the relay usually by rotating a dial or dials. The input control power can be a separate source of AC or DC voltage. The electronics become the brains of the device by determining the voltage and current level pickup values, which in turn sends a signal to an isolated contact and then a signal to trip the circuit breaker. Here is the recommended bench test connections for a current relay. The setup references a single-phase test current source. This setup can be used for three-phase relays, but since it responds to the average of the three-phase currents, a test current connection must be made for single-phase testing. This setup will allow for pickup and fault testing. The manufacturer's instruction book contains the procedure and tables for verifying the test and should be consulted before making the test. A typical bench circuit for a voltage relay calibration is shown here. Computer-based power monitoring equipment can be programmed to perform multiple functions in one package where several induction discs or solid-state relays would have needed to be utilized. In addition, the electronic unit can monitor and display many parameters, eliminating the need for metering and metering switches. This also saves on panel space. Most microprocessor-based relays have the ability to communicate status and trip functions onto a master central control system. The microprocessor relay can remember the system conditions that led up to a fault and maintain these values, providing an excellent troubleshooting tool for maintenance personnel. In addition, this data can be formulated. You just completed Protective Relay Essentials training provided by the Business Industrial Network. Please register to receive your certificate completion for this module by clicking the green box. After completing the short form, if you are located in the USA, a printed, ready-for-framing certificate will be shipped to you. If you are located outside the USA, a printable PDF certificate will be emailed to you. For more information on related training courses, please click the blue box below to take you to the Business Industrial Network website